So let me go over this really quickly. So coefficient table, the most important thing to look at here is the beta value and your t value and your significance, okay, your p value. One thing to make sure you note is that p is never equal to 0. So although it says that it's equal to 0 here, you never say that p is equal to 0 because that's impossible. P will always be something really, really tiny. So if I, double clicked on this, I would probably get, p is equal to 0.0000067889. But, to report this, you would say p is less than 0.001, which is just an indication that it's really small and really significant, okay? You would always mention your t value in addition to your p value because the t value is what is used to calculate the significance value. Won't go over that a lot, but you should know that the f or the t is what you use to calculate the p, okay? The reason it does that is because we have a t critical value or an f critical value that is that we use to compare. So this value is compared to a t critical value that changes with the degrees of freedom, which is dependent on the sample size, and therefore if it's either smaller or bigger, it's either significant or not. So don't worry about that. Just look at the t value and the significance value and the beta value. Oh, the ANOVA table, what you want to look at is the sum of squares column over here, the f value and the significance value, okay? So the coefficients table is to tell you if individual predictors are significant. The ANOVA table tells you if your model on the whole is significant, okay? So if there's a lot of stuff in your model, it tells you that everything interacting with each other is either significant or it's not. So, the R squared tells you the percent variability that's explained by your whole model in total. The coefficients table tells you the weight of each individual predictor that's being used to explain whatever the response is. The ANOVA table tells you if the model on the whole is significant. So what you want here is a really small residual and a really high regression sum of squares. The sum of squares has no units, so don't really worry too much about that. But what you ideally would like is to have the regression be a lot bigger than the residual. Okay, in this case it is, which is why it's significant. Okay, those are things that you want to look at.